Hello everyone. Our senior project was about process improvement at V10 Construction. I am Sharaf Al-Hello.
I'm Santiago Mejia.
I'm Naman Sinha.
And I'm Ryan Walty.
Our advisor was Dr. Elias Masayan. Here's an outline for this presentation. First, we're going to start with an introduction. Then we're going to define two problem statements. The first one is inefficient facility layout. The second, unproductive workstation and storage system. Then we're going to show improvement and cost analysis, and of course, end with a conclusion. Located in the city of Pacoima, V10 Construction was founded by CPP alumni Mr. Kakorian. They specialize in construction and luxury remodeling as well as interior and exterior design. Not too long ago, they started manufacturing some products like doors, cabinets, and more. As a company that is new to production, V10 Construction Facility is heavily reliant on random storage practices, random workflows, and an unorganized layout. By introducing an improved facility layout as well as expanding manufacturing to another facility, V10 Construction will be able to increase profits and productivity. One of their biggest problem was being unorganized, so we created a fishbone diagram and broke it up into 6 different parts. These parts are the causes that lead to their low production efficiency.
The next couple of slides are going to cover and summarize some data that we collected in order to help us with the solutions to our problems. And it's also going to help us provide quantifiable metrics. Here we have the machine utilization of the company. In this, each machine in the facility is listed as well as a percentage next to it. The percentage indicates the percentage chance that on any given day, that machine will be in use. It's also important to note that there's additional machines with 0% usage. This is because there's machines that are inaccessible or even just taking up space and not being used. V10 Construction is a make-to-order company. This basically means that they don't manufacture a product until a confirmed order is received. They produce cabinets, doors, ACM panels, fence rails, and tiles. Shown here in this graph is some production data for 12 periods. We can see that cabinets are being produced the most, with doors and tiles coming soon after. Here we can see a chart of their demand. The product ordered most by customers is cabinets. This is important to note as our project's improved layout is shown, and it's designed to prioritize products with the most demand.
And now I'll be talking about the inefficiency of the facility layout that is currently being implemented. Okay, here's the current facility layout in which you could take a good notice, in which you can see that looking at the facility layout, you can see that there's 2 buildings. One is the main building and one is the second building that is currently rented out. And there's this huge lot that they use for either parking and also storage for any material that can be fit inside the storage. On the far left, you can see a bunch of arrows. This is to implement, in a sense, what each color goes through in order to production. Blue arrows are the ones that go into the cabinets, doors, which is technically roughly the same layout and same flow, as well as tiles, AMC panels, and fence rails. One thing you can clearly notice that all of the arrows are focused on the bottom left of the facility, because if you look at the top left, that's actually where they hold their construction storage for any jobs that they do. As you can see, there is red red text that's on the machines. That's to indicate that those machines are not being utilized at all because of the minimum storage space. The minimum space required for them to be used is not being met. Here we create an activity relationship diagram in order to see what what's the average throw through each material, and then we came to a conclusion in which if you see a bunch of U's, that kind of indicates that those machines have no relation with one another, which makes sense because the majority of their production is using between 1 or 2 machines, but there's so much space that's not being utilized, so and which makes it more accessible to create a different layout for the machines. And here we create an improved facility layout. Firstly, we started with the new facility. What we prioritize in putting in the new facility is the the 2 laser cutters as well as the water jet, mostly because those machines need the most space in order for the forklift to pick up the material that can be carried by hand, as well as like tiles and metal sheets, to be able to unload and unload to the machine. We as well put in an additional workstation that could be, in a sense, could be used in order to do additional workage on any of the materials that still need to be worked on. If you look at the old facility, one thing we did is create a new workstation K, which will prioritize in the manufacturing and the cabinets and doors, because those are the most utilized, most produced material, and we'll be looking at more into the K station of what we did. Here's our current versus improved layout, in which we calculated the distance score from before and after and saw a roughly 9% improvement, as well as we saw an adjacency score of 12%.
One of the main issues faced at V10 Construction was their unproductive workstations and solutions for storage. As you can see in the picture, their workstations are very unorganized and sporadic. The processes used are based on memory, and there's no designated spaces or markers for items to be placed throughout the facility. There's also no specific destinations for work in progress or finished product, and as you can see in the picture here, they're even using cabinets as storage for scrap and other work in progress. This leaves them susceptible to losing orders, as well as losing product due to damage from scratches due to improper storage and handling techniques. This system is also very inefficient for new hires, as it is very hard to get them situated with the layout of the facility and where everything is located. Here you can see another example of a workstation at V10 Construction, where there is work in progress stored on the table that is supposed to be used to build the product, along with scrap boxes and other tools for various other machines and equipment located throughout the facility. Here you can see the layout of our improved workstation K. It'll have a specific location for raw material storage, as well as a location to do work on gluing the doors to make sure they are fit properly. It'll also have work in progress storage for the cabinets and doors, as well as a location designated for scraps and finished product storage. As you can also see, there is a wide gap in between the finished product storage and the work in progress area. That is so that the forklift that they use can make it inside to deliver the raw materials needed for operation. Since the V10 Construction is not being able to move into the new facility until January, we've suggested some additional 5S improvements that they can make once they move in, such as signage to designate specific locations for material storage and work in progress, as well as create written procedures to follow to ensure that all operations are able to be performed by every employee, and that each one does not need a specific employee to do the job. We also suggest that they create measured standards for all operators to be able to compare their work with to assure quality of their work. We also suggest they create additional specified storage areas for work in progress, raw materials, scrap, and finished product. That way, travel times are reduced throughout the facility. In order to combat the issue of sound in the facility, since we are unable to move all the machines to the second building, we suggest that they invest in sound deadening material as to better increase the productivity of those in the office.
We wanted to know if our new improved layout would actually show improvements over the original layout. Using Promodo, we simulated the process of manufacturing some products using the old versus new layout. A significant improvement was observed. For cabinets, previously it would take 25 hours of work to produce a batch of 49 cabinets. However, when implementing our new layout, the time it takes to manufacture the same batch becomes 22 hours. That translates into 14% efficiency increase. We also simulated the process of making doors. Previously, it took about 1 or 3 hours of work to make a batch of 80 doors. With our new layout, we expect them to make that same batch in 101 hours.
In order for the expansion to make sense, it had to be obtainable to cover the cost of the expansion with production. The current building that they're looking to expand to is roughly 4,600 square feet, rented out at $3 per square foot, giving a rough estimate for the monthly cost of rent of close to $14,000 a month. We found through the addition of additional 24 cabinets or doors, 4 perforated panels or AMC panels, and additionally 4 tiles cut on the water jet machine, they would be able to cover the cost of the expansion. We also found that if they were to run under optimal conditions at full production, they'd be able to see a profit of over $100,000 per month.
With shown improvements to the facility layout, storage system, and an expansion to their second building, we believe that V10 Construction can increase productivity and profits while improving product quality and customer satisfaction. Thank you.
All right.
Okay, that
Yep,
was
sorry about that one.
that's fine.
That's
It was
fine.
that was roughly around 13 minutes.